Hello and welcome to Chapter 8. With Chapter 8, we get to play with lots of rational expressions. Today we will be specifically multiplying and dividing rational expressions. So this will take probably a couple different videos just to break it up. So first of all, simplifying expressions means we're going to take all of the multiples and cancel them out. So for example, if I had, like a 2y over xy, to say that I was simplifying this would mean that I'd say, oh, I recognize that I don't need both those y's because y divided by y is just 1. So the answer is 2 over x. That would be simplifying that. So that's what we're going to do, but of course we're going to do it on a much more difficult scale. So simplify each expression. We'll get to the second half of that question here in a second. What you want to do is look at what you have and decide if you can factor anything. And when I look at 1a, I look at the top and I say, I don't think anything needs factored. That looks like it's exactly 4y, parentheses, y minus 3, close parentheses, open a new set for the y plus 4. Now that bottom half, that little trinomial, y squared minus y minus 6, that looks like it can be factored. And if you remember how to factor, I'm trying to figure out what adds to the linear term, which is the number next to the plain old boring y, so that would be -1. And what's multiplying to the constant term, or the number that's just being added. Adding, multiplying, and it looks like the answer to that is going to be -3 times 2. That multiplies to a -6, and it adds to a -1. My chart's a little off, but that's what I want. Which means this factored is y plus 2 and y minus 3. Or you can write it in the other order. It doesn't matter. So what I'm going to do now is, first of all, just include this little y that was there. So I'm just going to write that y. And then instead of writing that trinomial, I'm going to write my factored y plus 2 and y minus 3. Perhaps, I think I wanted to write this. Step 1. Oops, that's supposed to be step 1. I do not know what's going on here. Here we go. Factor the top and bottom. Okay, step 2. Cancel out the things that are the same on top and bottom. You might want to write this down. Hint, hint. So on this example that I'm looking at, I can see that my y's will cancel, as will the y minus 3. Looks like that can cancel. Okay, so step 4 is to write the final answer with the stuff that's left over. I'm kind of running out of crunching into myself, aren't I? All right, final answer with stuff that's left over. So in this case, it would be the 4, the y plus 4, and the y plus 2. Okay, so that is how I figure out, or that's how I simplify it. So the first part of that question is done. What I haven't done is answered this part. Under what conditions is the expression undefined? What it's asking is, when does the bottom equal 0? Because if the bottom equals 0, it's impossible, or it is undefined. So what I'm going to do now, this is kind of like secret step 4, and maybe I'll write it even in a different color. Go back to the factored denominator, not the simplified, the factored. And solve for the zeros. And again, I'm kind of crunching into myself. those are going to be the impossible solutions. So what I do, again, the factored bottom, that's this step here. Every piece that is being multiplied is one that you need to set equal to 0. So this one has 3 pieces. 1, 2, 3. Like that. So I'm going to say y equals 0, y plus 2 equals 0, and y minus 3 equals 0. Solve those. It turns out the first one is just plain old boring y equals 0. The second one, if I subtract 2 from both sides, I'll get y equals negative 2. And the other one I have to add 3 to both sides, so that's just going to be a positive 3. That's part of your answer. You cannot forget it. Okay, so one way you can write that, by the way, to simplify things, is you can just say y cannot equal 0, negative 2, 3. Because when I plug those back in to the original piece up here, let me use the highlighter so you can see that better. When I plug that into that piece there, it would give you a 0 on the bottom. You can't divide by 0, so that's why it's impossible. All right, so that's example 1. Okay, so now we're going to do that exact same thing again. So step 1 is to factor everything. This time, instead of having a trinomial to factor, I just need to pull a z out of the top. So z x minus 4 and z squared 4 minus x. Now I'm pausing for a second because I can see that x minus 4 and the 4 minus x are really closely related. If I try to rewrite them where x is first on both of them, I can see that they're still not exactly the same, because that would be negative x plus 4. But I notice that the negatives on both parentheses are just completely flopped. So what if on the top, instead of taking out a z, if I had taken out a negative z, I'll try and get that written in there, then that would have meant I'd had a negative x and a positive 4, and now I have negative x plus 4 on both the top and the bottom, which will allow that to cancel. Okay, and then I also go, oh, hold on a second, I have a z on top, drop my pen, a z on top and a z on bottom, so one of those will cancel. This is where things get a little funky. What's left over? On top, everything canceled except this negative sign. So there's a negative, what's the coefficient here? 1. So there's a negative 1 on top, a z on bottom. There were 2 z's, one of them canceled, so there's only 1 left. And that, ladies and gentlemen, is your answer. Except for step 4, where you have to figure out what the bottom can't equal. So then I come over here to the factored part, which actually was the exact same, so that wasn't a big deal. Some of you can probably do this in your head. So included in my boxed answer should be that z, I guess I didn't show that I did the square root over here, did I? There we go. Z cannot equal 0 or 4, and that is my final answer. All right, I'm going to pause there and make another video for the next part.